The X-wind is an astrophysical model for the early solar system and illustrated here on this sketch. I will only highlight those characteristics that are important for meteoritics. Now, the term X-wind basically comes from the fact that there are magnetic lines, shown here as these gray lines, that have a crossover here in the accretion disk. So here's the accretion disk, and the magnetic lines cross over here. And this is over a certain range, which is called here this reconnection ring. Now, this reconnection ring has the potential to heat and melt solids, for example, chondrule precursor aggregates. So tiny fluffy balls consisting of fine-grained material that are heated, molten, and then cooled down again, thereby forming the chondrules. And this heating is also done in a very short time interval. So basically here in this region of the reconnection ring, there's the potential of briefly heating the chondrule precursor material, forming chondrules. Now, this reconnection ring and this X point, so this is basically this entire thing is the X point, is an X region, has a distance from the Sun of about 0.06 astronomical units. So it's very, very close to the Sun, this X point. And also there are from this region from this X region away, there's an X wind that moves outwards into the outer parts of the solar system. So the idea then from looking at this model is, or the suggestion from this model is, that chondrule precursor material, so if there's some chondrule precursor material that is in the X region here, is processed, and then chondrules are transported with the X-wind over the protoplanetary disk into the outer regions of the solar system, where it rains down again and is mixed together with fine-grained material that then forms matrix material, and together fine-grained matrix material plus chondrules then form the chondrites. So this is essentially a two-component model. So there's the X region, material is processed, chondrules are formed, moved above the disk outward, raining back down on the disk, mixing with fine-grained material, thereby forming chondrites. This is the basic idea of the X-wind model. Now, of course, a critic with the X-wind model is that it's a two-component model, and it requires two reservoirs, one in the X region, one in the outer part, and this is mixed together. This would be in conflict with, for example, other suggestions that chondrules and matrix formed in the same reservoir as required by, for example, complementarity. Still, this is one possibility. Finally, CI material would be mixed in, because CI is likely also formed close to the Sun where it was hot and material could have condensed. So CI material was mixed in with the chondrules, and together with the chondrules is moved outwards into the outer parts of the solar system. So in this sense, CIs might still be some senolytic component that formed elsewhere close to the Sun, mixed with chondrules, both transported outwards and also mixed with the matrix there together to form the chondrites. And this is very briefly and in essence what the X-wind model means.